is, for those of you with no idea what you can do with it, and then some more detail on how it actually works and why this is important. And what I'd really like to get to, hopefully, is that people think it's useful and some discussion of whether this is useful beyond the world of Debian and Ubuntu, where it currently exists. Multiarch fundamentally is quite a simple thing. It's just a way of installing libraries for more than one architecture on the same system, or within the same file system. Obviously, this problem was sort of solved when AMD64 came along with lib and lib64, which is what SUSE and Red Hat did. The problem with that is that you have to special case AMD64, and Debian didn't like that much, so we didn't, and instead produced the abomination that is IA32 libs. So a few packages in Debian are built for both 32-bit, 64-bit, but most aren't. And so all the things that you actually need in order to run 32-bit apps on a 64-bit system go into one gymongous package, ie32 libs, which is installed in /emul ie32. The problem with that is that it's a maintenance nightmare, because every time any of those packages change, you have to upload a new version of this totally stupendous package. So, Multiarch is fundamentally not complicated. The basic concept is astonishingly simple. In order to install multiple architecture libraries on one system, you need them not to have the same file names. So, instead of putting libfoo for whatever architecture you happen to be using in user lib, you put all libraries in architecture qualified directories. That's it. I mean, we'll go home now. The problem is that changing that from where we are is a big deal. Everything knows perfectly well where the libraries are. You can't just go moving things around and expect everything to work. The advantages of this are significant. It's quite a fundamental change. So the way I found is most useful to think about it is that now libraries have a canonical path for whatever architecture they are. So there's just one place where the ARM EL version of lib whatever will be, always. And it doesn't matter whether you're running under QEMU, or you're running in a sysroot, or you're on native system, or you're cross-building. It's always in the same place. So the paths don't change. So especially if you've done a lot of cross-building, you'll know it's a right pain in the arse when you're trying to link against the library over here, but when you install it, it's going to be somewhere different, and you've got to get libtool to do the right thing. All that just goes away. It's marvelous. At least in principle, this can also cover the cases of running things like Solaris on Linux, which I don't guess anybody does much anymore, but there is a special directory to install stuff in if you want to do that, and you could just use Multiarch. So, most of the driver for actually doing this has come from the fact that ie32 libs is horrible and a massive pain in the bum. So, as Tollef pointed out, it's now the biggest source package in Debian, and he pointed that out in 2005. It hasn't got any better since then, as people keep adding wine libs to things. So this was a temporary scheme to deal with the fact that we weren't using the lib64 mechanism, but it's taken quite a long time to fix it and do it properly. Just some idea of how this went. So back in 2004, Tollef Fogheen wrote a nice specification saying this is how Multiarch should work. There were a few ifs and buts, but basically that was the plan. Move things into architecture qualified directories. And then there was a talk at DebConf 5, and people went, yeah, okay, that's a good idea. And there was a significant meeting here, and everyone went, yeah, yes, let's do this thing. A couple of years after that, finally some patches for dpackage turned up. Not many people like hacking dpackage. It's not a very satisfactory, pleasing activity. And you need patches for GCC and a whole load of work. And so one of the things we realized during this process was that you have to scale down the size of your plan. If you want to fix everything in the whole world at the beginning, you'll never get it done ever. So by restricting the process to just the library part of this and not worrying too much about the cross-building part or the running multiple binaries or all the other things cool things you could do, we did eventually get it done. And I must congratulate Steve Langasek for driving that process for about the last 4 years and banging heads together and saying, no, we're not worrying about that part, just do the bit we do know, understand, don't try and do everything at once. So, as of about a year ago, this was working in Ubuntu. It turns out this sort of thing is easier to get done in Ubuntu than it is in Debian, because if you can persuade the powers that be that this is what we're going to do, then you can just tell people to stop arguing and get on with it, whereas of course it's slightly harder to do in Debian. In fact, we still don't have Multiarch depackage in Debian, but it looks like that problem is being fixed as we speak, and you'll probably get it on Monday. So, once the infrastructure was in place, you can fix every library in the world. So the current state of play is that all the core stuff in Ubuntu is done, basically. And we've done quite a lot of packages in the whole of Debian, but there's still quite a lot to go. It's a nicely parallelizable task. Once you've set up the stuff, all you have to do is tell each packager what they need to change. Ideally, have the tools do it for them. In general, library fixing is not difficult. So if you've got a library and you want to make it multi-arch compatible, there's a web page, just do what it says, you'll be fine. Dev packages are a little bit more complicated. So, that's the basic, what is it? What you can do with it. I've mentioned a couple of these things already, but we'll have a little bit more detail. So, it's now very easy to just install a few, or one random ARM binary in your system and have it run under QEMU. Generally, up till now, it was much easier to make a whole cheroot and run that under an emulator. Whereas now you just stick a package in, it'll automatically bring in its own libraries, so it should just work if you point QEMU at it. Cross-compilation is dramatically improved from being a massive pain in the arse to much less of a pain in the arse. It doesn't solve all your problems, and I'll cover that in a bit more detail later, but it does help enormously because of the canonical path location thing. There is a place where the file is, and it's not going to move about, it's not going to be different later, and so on. You can cross-grade. This has always been a problem when people improve their ABIs, especially those ARM people. Oh, damn, that's me. Every couple of years or 3, we go, no, we don't like that anymore. It's all changed. You have to do it like this now. And so all the poor people with slugs, I guess, running old ARM, it's quite hard to upgrade it to ARM-EL and not get left behind as it just gets abandoned. In fact, it's more or less impossible. Multiarch makes that fairly straightforward. So long as dpackage doesn't explode in the process of changing its native architecture from the old one to the new one, you can install the whole system, all the new stuff, and then just switch over dpackage to say, my native architecture changed, carry on as before. To be fair, there are still some wrinkles around that if you actually try it today, but it can work, and it will work smoothly quite soon. The other reason, which actually, again, is one of the main drivers, even though obviously as free software people really don't care very much, the main reason people want to install 32-bit stuff on 64-bit systems is because all they got was a binary off the internet. They can't fix it, they can't rebuild it, and it needs 32-bit libraries. So, Flash plugins, Skype, Xilinx tools, all that evil software has in fact been quite a significant driver for making this stuff work. And now it's dead easy. So in fact, the first set of packages to be multi-arched in Ubuntu was the set of libraries you needed to install 32-bit Flash player on a 64-bit system, just because that was a useful and not too enormous target. I think that was 83 packages. So, just to be clear about what multi-arch isn't, it's not about installing more than one binary tool of different architectures. This is just about libraries. So you can't have both the ARM and the x86 versions of Mozilla installed and then decide which one you want to run. Now, that would actually be useful, but that's not what the spec deals with. That was one of the things we went, no, we're not going to worry about the binary part of this, we're just going to do the library part of this. We can move on to the binary part of this later. So if anybody is really keen to see that functionality, see me. Actually, see Steve Langshek, because he is the man, really. The architectures which are split are ABI incompatible architectures. So there's lots of variations you can have within an ABI, which is usually about, does my CPU have this extra bit or bob or floating point unit or SIMD unit or whatever. Those are ABI compatible, they're just hardware capabilities. So triplets and GNU in general have been a bit vague about distinguishing between ABI differences and hardware hardware functionality differences in terms of exactly what a triplet means. But Multiarch is just about stuff which is fundamentally incompatible, so it needs a new architecture. So the multi-lib thing in GCC is different from Multiarch, and that's about having multiple libraries, you know, a neon library or a non-neon library or an MMX library and non-MX and so on. I hope that makes sense. Do shout if I'm talking nonsense. But if you ask really hard questions, I probably don't know the answers. Sorry? Closer, right? Will do. Some of the other things you can do because of the existence of this technology is partial architectures. So, for example, a PowerPC 64 I think is quite a good example, if I got that right, because it's no faster running the 64-bit stuff than 32-bit stuff. So most of the time you just wanted the 32-bit versions, but for a few apps you'll need 64-bit stuff. So it's now possible to have an architecture which is mostly composed of the 32-bit version, and you can just have a few packages built for the extra architecture, and you all just install it together and it just works. We're not doing that in Debian yet, but we do now have the technology to do that if it proves sensible. Yeah, and it saves you having to build another 20 gigabytes of software just to get the few things you really cared about. Cross dependencies is, so you can have dependencies between architectures now. So the canonical example is cross compilers. In order to build a GCC targeting ARM, you need the ARM version of libc. So it has a build dependency on the ARM version of libc. Now, at the moment, you can't do that in Debian. You just have to have some horrible package that downloads all the sources and does a bootstrap in place, or you build it yourself magically and just upload it to the system. So the build the infrastructure can't do that, or it couldn't until now. Again, we still don't actually allow this in the archive yet, but we will do any minute now. And in principle, you could have cross-built architectures if you really wanted. You could probably have done that before, but it gets easier. So that's all what it's for. A little bit about how it actually works. So we move libraries into qualified paths by architecture. Now, the only problem is that you have to pick a path. And you have to pick a path once and not change your mind later, because every single binary has the loader, the libc loader, well, any C binary, has the loader path baked into it. So you can't go around changing it afterwards because nothing will work. So this resulted in about 2 years of arguments about what the path should be and should we use GNU triplets or not. So as I said, the problem with GNU triplets is that they don't quite map to ABI incompatible architectures. It's mostly the i386 people who've invented 4 different triplets for the same thing. So i386, i486, i586, and i686 are all fundamentally the same thing. It's just like, have I got some extra instructions or not? ABI doesn't change. So we invented a new scheme which looked very similar to this, just not exactly the same, and then had a long argument, and in the end decided to use the GNU triplets as is, with just a bodge to deal with the i386ness. So it's always i386 Linux GNU, because that's the ABI, whatever actual CPU you've got. There's one tool which gives you the canonical path for a specified architecture. So dpackage architecture is responsible for knowing the mappings between Debian architecture names, GNU triplets, and multi-arch paths. That's good, because it's all in one place. You can't get different things having different answers. Sorry. The only problem is that that's a Debian-specific mechanism. So for upstreams, you need to do this, and for other distros, we need a proper LSB mechanism to provide the same information. I don't think that's difficult, but I don't think anyone's done it yet either. And they probably won't until somebody outside Debian decides this is worth implementing. So the way this works, so that's where you put the files and how you find out where to put the files. The other part of this is how dependencies work in a multiple architecture view of the world. So for years and years, apt only ever looked, the dependency set is closed within an architecture, and it didn't have to worry about other architectures. You could change it and say, just look at the whole file set for a different architecture and solve it there, but you couldn't look at two at once. So fundamentally, I found the easiest way to think about this, the terminology for all this is confusing. I don't know how many of you used to the GNU build and host, where host means target, not build, and so on. If you don't do it all day, it's very confusing. Similarly, the multi-arch terminology, if you don't look at it on a regular basis, it does your head in. So I prefer to think of things, packages fundamentally fall into two groups, libraries or tools. So libraries are things which are co-installable. You can have lots of them for different architectures. And tools is, any binary which isn't co-installable. You just want one of it. It really doesn't matter whether your XML processor is the ARM version or the x86 version or the AMD 64 version. They'll all work and they'll all produce the same output, or at least they should do. Every package gets this field, multi-arch. Well, not every package actually, just packages which are multi-arch ready or needed for other reasons. And you just say, yes, this is a multi-arch same package, which means it is co-installable with other architecture packages of the same name, but it'll only satisfy dependencies within that architecture. Or it's a foreign package, which means it's just a tool. It doesn't matter which architecture. Anything that will run on this machine is fine. Just get me one. We also have to have allowed for some things which are both. So Python is the canonical example. It's got library parts in it, and it's just a tool. So it depends what you want to use it for, whether how you want your dependencies to work. Do you need Python of the same architecture, or do you just want any Python because it will run Python stuff? And so in that case, the dependency depends on the thing which is doing the depending, whether it wants the same architecture or a different architecture. And this all works fine, except that every package, as well as having libraries in it, every library package, has at least documentation copyright file. And that's not architecture dependent, and it will be daft to have a copy of it for every architecture in a special path. So dpackage has reference counting to deal with stuff which is the same, files which are the same across every architecture. So when you take the last version of the package away, then it removes the file. But each time you install a new one, it just says, yeah, okay, we've got, in theory, 3 copies of that now. So this is how you use it in practice. It's very simple. You say, so let's say you're on an AMD 64 machine. So you say dpackage add architecture i386. So now you've got both. Strictly speaking, that's the command you will get in Debian in about 2 days' time. At the moment, if you're in Ubuntu, you use the bottom one, which has exactly the same effect. It just means that it isn't nicely organized in terms of adding and removing architectures with tools, because you might overwrite whatever it said before, or have 6 copies of the same thing because you've run the program 6 times now. So that now means that dpackage will consider or allow packages of another architecture to be installed. In practice, you use this through apt. So you have to tell it where it can get packages from. So I imagine most of you are familiar with the apt source lines telling you where you can get stuff from, and now you just qualify them with which architecture is available from which sources. It's particularly important in Ubuntu world, where they put all the ARM stuff in a different repo from the x86 stuff, just to annoy me. And the release files claim that both archives have all of the architectures. They're wrong. Very wrong. And it's too hard to fix, apparently. apt for many years has had an architecture flag, which, as I said, just let you switch between what is the architecture I'm considering when trying to solve this package dependency set. And that's been very useful for a long time. But now it has the ability to make a list, which is the set it's going to solve over right now, which in practice it gets from dpackage's configuration and is invariably the native architecture and all the foreign architectures which you wish to consider. So once you've set that stuff up, which wasn't very hard, now you can do an update and you can just install packages and qualify them with architecture names. So long as that's an architecture you've said is a foreign architecture or a native architecture, just install stuff. And apt solves the dependencies and goes, that's libatter dev will need libatter :rml as well, so I'll install that for you. And get selections obviously now lists. So basically everything in the whole interface now has :architecture on the end, optionally. If you don't put it in, you mean the native architecture. So that all works now. In fact, I've been working for a year or so in Ubuntu. Cross-building. So this is actually the area I've been mostly using this in. There's three major pains in the bum. Installing things. So in order to cross-build anything, you need to have all the tools you need, and you need to have the cross libraries and headers for whatever it is you want to build. We have not had a complete way of doing that automatically in the last 10 years. We've had all sorts of mechanisms and bodgery and hackery. If you have a look at how xdeb works, it's got a great big list of things called lib that aren't libraries and things that aren't called lib but are libraries in order to try and work out whether it should install the native version of something or the cross version of something. That's about the level of how swish this has all been. All this just evaporates with Multiarch. Actually, next slide. You also need to find the libraries in order to link to them, and you need to run tools at build time, which may or may not be for the right architecture you're trying to build on. So yes, the dependency thing. Generally, everything you need to install is either a library or a tool. Sometimes they can be either. Now, the obvious way to fix this is just to annotate your build dependency list in everything and say whether this is a cross dependency or a native dependency. That's simple. But you would have to, make your dependency list in every package in the world twice as long. And then it became clear a couple of years ago that the multi-arch information is almost exactly the same information. Not quite. But basically, you know whether everything's a library and satisfies dependencies within the architecture or it isn't, and will satisfy dependencies for any architecture. The thing is that information is specified in the package, whereas the dependency relationship is from the thing you're trying to build onto what it's going to install, i.e. the other way. In practice, this just means that all you have to do is annotate the exceptions to the rule. So where it's a library, but actually you want the build version rather than the host version. We have, in fact, found almost no instances of this yet. And where you do, it's usually easier to split the offending package. So Flex is a good example. Flex is both a tool and a library. It's actually easier to just split it into libflex and flex, and then everything will just work, than it is to annotate all the instances of it to say which one it was you wanted. Or if, in fact, you wanted both. So this is a great improvement. Runtime and build time library paths are now the same. So if you've done much cross-building, you'll have discovered the great joy of trying to get libtool to understand that you want it to link against your library here, but at runtime it was going to be somewhere else. Please don't screw it up. libtool's very clever if you really need to build for HPUX circa some time ago, right? But mostly it's a pain in the arse. And if you ever tried to fix it when it's not doing the right thing, it's even more of a pain in the arse. So this problem pretty much just evaporates with Multiarch because the path is in the same place at build time as it's going to be at runtime and at install time. It's just the path. So suddenly it's very easy for your tools to get it right. And millions of instances of dash dash libdir equals this, that, and the other when cross-building become unnecessary because it's the standard system path. There's also this problem of tools that get built at build time and might be for the wrong architecture. We can mostly just cheat and use QEMU now. You could do that before, but in practice, people tended to use things like Scratchbox, which was a whole load of complexity, or OBS, to make this work reliably. I'm reasonably sure it's all just going to become easy, but we'll see. So, apt-get build dep is how you just say, please install build dependencies for this package. Now you can say apt-get for a particular architecture, install the dependencies of this package. So, or across architecture. So apt will just solve your stuff and work out that it needs, the RML version of various libraries, but all the tools, it just needs the normal version, and will install things. That's a real run I did 2 days ago. Actually works. Brilliant. And now, to be fair, of the 400 packages I built, about 25 of them did the right thing. But, we can fix that. There's an auto builder online now, so you can all see whether your packages don't work. For a complete solution for this, we actually need to deal with dev packages and headers as well as just libraries. So, as I say, we restricted the scope of Multiarch for years to get it done. So the dev package stuff and headers was put to one side. Now, there is a spec for that, but it's not a requirement to make the Multiarch library stuff work. It is a requirement, and it's not even a requirement to make cross-building work, because you can just install either one dev package or another. You generally don't need both. There's only a few packages where that's actually the case. But in the long term, we'd like all the dev packages to match up and do the right things. So that basically means that you can't have binaries in your dev package anymore, because if you've installed one for some other architecture, the binary won't work. Binaries in dev packages tend to just be random config scripts that do crazy config shit when they really ought to be using package config. If any of you have ever looked at libapr, which is the Apache configuration system, it's amazing. Invented all this marvelous stuff to try and do cross-building, right? But they've done it wrong and it doesn't work. And I don't know what the hell they were thinking. I've got a really long mail. It's like, I don't know, it's about 20K of stuff saying, what on earth were you thinking? So, to make all this work, we had to do quite a lot of stuff. Anything which knows where libraries are needs to be changed to understand multi-arch world. So obviously libc and GCC and dpackage and apt are the core things. But it turns out, so for example, the system library and header paths you get when you put squiggly brackets around things and dash and don't specify a library need to include the multi-arch path now. It turns out there's a whole lot of other things that know where stuff are. So if you've ever used the old-fashioned make target dash little l library name, that doesn't use the compiler or libc or anything to find out where the libraries are. It just knows, and it's wrong. So you have to fix that. And package config obviously needs to understand that any other make systems, CMake, I guess AutoTools should be in this list, but maybe they just did the right thing. So anyway, OpenJDK needs to know when it's using the JNA stuff, because that links to native libraries, so it needs to know where they are. Even dpackage cross, which in principle is now irrelevant in this new glorious multi-arch world where pretty much everything it did is stuff we don't want to do anymore. It still needs to know where the libraries are in case you use it in the meantime. So all of this got done about a year and a half ago so that you could start uploading packages. We've got a load of information online for people who, for packages, because as I say, this is highly parallelizable. You just have to get all your packages to do what they need to do. Some useful tools have been added. So the interesting difference is that if you look at Debian package files to date, never generally, in all the install files, Debian stuff, never used to have to specify variable paths. They were just paths. Until now, where every library needs to say user lib, well, whatever architecture I'm building for today, So some mechanism has been stuck into Deb Helper to make that easy. Nothing else of great interest there. So one of the things which we, as I say, we didn't do was arrange for co-installable applications. I've already come across various instances where people would like to do that. They go, oh, well, I've got this nice Multiarch system, but I can't install both versions of this and then just benchmark them. And you go, no, you have to install one and then remove it and install the other. I mean, okay, it's not very hard, but so for people who need that, we'll have to work out a scheme. You know, are we going to make all the bin paths architecture qualified? Quite scary. Or are we going to do something clever with bin format MISC? There's various possibilities. And finally, why is this important? What do we do next? And what do we learn? So this is, I missed the talk earlier, unfortunately, about major changes in distros, but this is another one. It's really quite hard to change fundamental infrastructure in something that's already been running for 15 years. But if you've got a good reason and some competent people and enough people who actually care, it is possible. Perhaps the most important thing is to write down a detailed spec. If you read the Multiarch spec page, it is really boring. It goes on and on and on and on, in incredibly detailed and impenetrable language to actually specify what needs to happen in all sorts of obscure circumstances. So part of the reason this took years was because we had a sort of proposal saying, we could do this and this and this and this and this. But that's not the same as saying, you need to do exactly this and exactly that and exactly that, and if you specify this, it needs to be like this, and there's no space after the colon, and all that rubbish. That made a huge difference. Once we'd actually got that specified, everyone went, oh, okay, we'll do that. We can do that. So that's probably the most important learning from this long process, is write detailed spec and then point everybody at it. And also, the bit about controlling the scope, to not try and do everything that's possible at once, pick a part which can be done independently, and then just do that. And of course, design to avoid flag days if you possibly can. We slightly screwed that up. We still actually have to depend on Multiarch support package because of libc-ness, which we were hoping we wouldn't have to do. So, this is quite a significant change. It's slightly difficult to convey how marvellous it is until you actually try it. You know, I have been really quite impressed by all this now that I've started using it. It is great. It's nice that 10 years later we have a proper solution to the multiple architecture library thing. We've done it, it works, people are using it, but only in Debian and Ubuntu and derivatives at the moment. So this is cross-distro world. I have no idea whether the Fedora people are interested in doing this or not, or quite happy with their world at the moment. It's not too bad. Everything works as long as you've got x86 and MD64. But like, it's a lot more complicated once you've got AArch64, which is the ARM 64-bit stuff, and ARM-EL and ARM-HF, and all the other stuff. So Debian has always lived in this world of having loads of supported architectures. Other distros less so, but I guess they're all supporting ARM, so they're beginning to notice. So that's all I've got to say. I'd be interested to know if anyone here does think this is something they'd like to do outside Debian, and if so, how we might do that. Or if you've got any sensible questions. People would find it useful, so they want to know about the co-installable binaries part of this. This always happens. You go, look, we've done all this cool stuff with the libraries, and they go, yeah, that's nice. Well, we want co-installable everything. And you go, yeah, well.
Not just academic. I mean, situations like diskless workstations, which is multi-architecture.
Because they're loading stuff over the net, so they might get binaries for a different architecture.
It might, for example, be in people's home directories, or, you know.
Yeah, I mean, as I say, I think it will be useful, but somebody needs to sit down and think about the details of where, what does the path layout look like, path structure, and how do we deal with that when people have got the wrong binaries, and we're relying on the mix of emulation versus compatible architectures, and so on. So yeah, I mean, there's quite a lot of compatible architectures, most of the 3264 things within an architecture where this just works, as long as you've got somewhere to put the files. So, and how many things do we have to just change the bin? If we just add another qualifier to bin and leave a symlink there for the old compatibility, does that just work, in fact? I haven't thought about it in detail. This is where Steve Langersek will be a better man to stand here, because he has thought about it to some degree. Yes, I think people want to see this happen. That is kind of part 2 of this process. I don't have a detailed plan. I care that the cross-building part works at the moment, and we've done all the infrastructure work, but now there's a whole load of work to do. But yeah, if anybody cares, please write a specification. So yeah, so he's asking how long it'll be before we get all the headers and dev packages done, as well as just library packages. It's being done at the moment. It's just that if you read the specs, it just says in various places, you as a package, you don't have to move all your headers, even if they're architecture dependent yet, because it's not decreed. But the cross Multiarch spec says, please move your headers if they're architecture dependent. And you do need to test that things still build with these. Sometimes you move the libraries and your dev package breaks anyway. So in general, we are fixing all the dev packages. At the timeline, I mean, there's 6,000 packages. I don't know how many dev packages there are, a couple of thousand. We've probably done about 40 so far, or something. So it's just an ongoing process. In practice, you can build an awful lot of the system with a relatively small subset of the system. So, once we've done 200 of them, most stuff will probably work. I imagine we will have a good chunk of it done this year. So asking whether this is important for small systems as well as desktop-sized systems. Mostly from the cross-building aspect. If your system is constrained, you don't generally want to be installing multiple architectures of stuff. Yes, so it's really useful for building stuff. And for testing stuff. It's now trivial to just install your all the package. You've got your system, and you can just install the ARM binary you just built and run it here. You don't need a special environment anymore. You've got the environment with the qualification, which is important to understand, that everything is in version lock. So all this Multiarch stuff only works for the same version that's installed on your system. Now, if your embedded stuff is all either randomly ancient or randomly brand new, then you can't just cross-install the libraries without also installing, or at least having the same versions built for your build system. But so long as you're prepared to live in a version-locked dev world, then you can just run everything on your system without having to do anything. And obviously, it's not difficult to have a chroot and just do the Multiarch stuff in there. But you don't need another layer. Well, that's all. So we haven't got anyone here from Fedora and SUSE going, that's a brilliant idea, we should do that as well then. Fair enough. Thank you very much. Talk to me afterwards if you need to know anything. I hope that was useful.